Welcome to the LMWC Learning Mathematics with Ms. Choekyi channel. Please do hit the like button and subscribe the channel.
Hello everyone. So today we are going to do the exercises question of chapter number 1. So in real number we have two exercises. So first let us do the exercise 1.1. So the first question we have: express each numbers as a product of its prime factors. So we are given few sub questions. So the first sub question is 140, and we are asked to express this as a product of prime factors. So for that we have to do the prime factorization. So first let us find out the prime factorization of 140. So we need a vertical line and a horizontal line, and put the numbers in here. And we need to find out the prime factors of 140. So 140 being an even number, we will start with the even prime, which is number 2. So 2 times 70 is 140. And again, 70 being an even number, continue with 2. So 2 times 35 is 70. And 35, so it is a factor of the number 5. So 5 times 7 is 35. And 7 times 1 is 7. So now the prime factors of 140, you have to express it in this way. So 140 equals, write down all the prime factors in this column. So we have 2 times, and we have prime number 5 and prime number 7. So this is the answer for the prime factors, the product of prime factors of number 140. So like this, we have to proceed for the next sub questions. So next we have 156. So 156 being an even number, so again we will start with 2. So 2 times 78 is 156. So 78 being an even number, again we will start with 2. So 2 times 39 is 78. The factor number 3, so 3 times 13 is 39, and 13 will be the factor of 13 itself. So therefore, the product of prime factors of 156 is 2 square times 3 times 1, 3, 13. So next we have 3825. So the last digit being 5, so it has to be divisible by 5. So 3 times 765 is 3825. Then again the last digit is 5, so it will be 5 times 153 is 765. Now the last digit is number 3, so it will be divisible by 3. So 3 times 51 is 153. So 51 is again divisible by 3. So 3 times 17 is 51. And 17 times 1 is 17. So therefore, 3825, we can represent it as. So now here you can see 5 square, and over here 3 square. So 3 and 5, so 3 is the smaller number, so we will start with the smaller number in the increasing order, and next we will take the 5 square and then the number 17. Next we have 5005. So this will be divisible by 5 since the last digit is 5. If 5 times 1001 is equals to 5005. So for this next number, it will be divisible by 11. 11 times 91 is 1001. And 91, it will be divisible by 7. 7 times 13 is 91. And 13 times 1 is 13. So therefore, 5005, we can represent it as 5 times, 7 times, 11 times, and 13. Next, we have 7429. So for this number, we can only find the prime number 17. So this factor will be 17 times 437 is equals to 7,429. And the next prime factor over here is 19 times 23 is equals to 437, and 23 times 1 is 23. So here we have the prime factors of 7,429 equals to 17 times 19 times and 23. So with this we are done with the first question. So in the second question, we have to find the LCM and HCF of the following pairs of integers and verify that LCM times HCF equals to product of the two numbers. So again, we are given few sub questions, and we have to find the LCM and HCF of both the numbers, and after finding them we have to verify it. So first we have to find out the HCF and the LCM. So for 26 and 91, so number 13 is the common factors of both the numbers. So here 13 times 2 is 26 and 13 times 7 is 91. So 2 and 7, we do not have the common factors. So 2 times 1 is 2 and 7 times 1 is 7. So here we have the HCF of 26 and 91 is the number 13, because 13 is the only common factors, and LCM of 26 and 91 is, so 13 times 2 is 26, 26 times 7 is 182. So now we know the HCF as 13 and LCM as 182. So for the verification, we will take down the formula, which is LCM times HCF is equals to product of the two numbers. So LCM is 182, HCF is 13, and the two numbers are 26 times 91. So after taking the multiplications of 182 times 13, so we will reach the answer as 2,366. Similarly, 26 times 91, you will get this answer. So since both the LHS and RHS are equal, so you will just mention it as verified, like this. Alright, so for the next sub questions, we are going to do the same way. We will first find out the prime factorizations of both the numbers, and the common factors you will take it out, and that will be your HCF. And the rest of the factors, whether it's a common or not, you will take out all the factors and take the product of it. That will be your LCM, and then you will do the verifications using the formula. So next we have 510,92. So 510, 92, you have the common factor as 2, since both being the even numbers. So 2 times 255 is equals to 510, 46. Then next we have 2, so 255, you just copied it down. So 2 times 23, then we will do the 23. So 255, copied it down. 23 times 1 is 23. So 255, we will start with the 5. 5 times 51, then with the 3. 3 times 17, and 17 times 1. So here our HCF is only number 2, whereas LCM is 23,460 will be your answer. So where for the verification, write on the formula, product of the two numbers. So LCM 23,460 times 2 is equals to 510 times 92. So taking the product of these two numbers, you're going to get 46,920. Likewise, you're going to get 46,920. So they are verified. So Although in the questions they have set to verify, but this verification is also for your informations that the HCF and LCF which you have just found are correct. Okay, so in case the verifications are not equals, if it's not verified, like LHS and RHS are not equals, then you have to recheck your prime factorizations method and try to get them equals. So next, 336, 54. So little starts with the times 168 is equals to 336. Then 2 times 27 is 54. Next we can do with the 3. So 3 times 56 and 3 times 9. Then we have 3. Well, 56, we'll copy it down. 3 times 3 is 9. Then 56, copied it down. 3 times 1 is 3. Then with the 2, so 2 times 2 is 4. 2 times 8 is 16. 2 times 14. 2 times 7. And 7 times 1. So here our HCF is 2 and 3, because 2 and 3 are the common factors. So 2 times 3 is 6. And LCM is equals to, taking the product of this, we are going to get the LCM as 3024. So for the verification, LCM times HCF is equals to product of the two numbers. So LCM, we have 3024 times 6 equals to 336 times 54. So taking the product of these two, we are going to get the answer as 18,144. Similarly, we are going to get 18,144. Hence, it is verified. Alright, so the third questions we have: find the LCM and HCF of the following integers by applying the prime factorization method. So we have to find the LCM and HCF using the prime factorization method. So let's do for this three numbers. So 12, 15 and 21, all these three are multiple of 3. So 3 times 4 is 12, 3 times 5 is 15, and 3 times 7 is 21. So for the next, we do not have a common factor, so we can take any numbers. So 2 times 2 is 4, 5 and 7 take it down. 2 times 1 is 2, 5 and 7 take it down. 5 times 1 is 5, 7 take it down. And 7 times 1 is 7. So here the HCF is only the number 3, and LCM is equals to, taking the product of these numbers, we are going to get as 420. (17, 23, 29). So for these numbers, we do not see a common factors. So 17 times 1 is 17, 23 and 29, copied it down. 23 times 1 is 23, 29, copied it down. And 29 times 1 is 29. So our LCM is equals to 17 times 23 times 29, which is equals to 11,339. So for the HCF, since we have not seen a common factors of these three numbers, so only one will be your answer. So whenever you see a situation like this where you do not find a common factors, then you will directly choose this number 1 as your HCF. Okay, so moving forward to the next question: 8, 9 and 25. So again, 8, 9 and 25, I cannot find a common factors here, so I'm going to focus on the number 8. So 2 times 4 is 8, 9 and 25, copied it down. 2 times 2 is 4, 9 and 25, copied down. 2 times 1 is 2, 9 and 25, copied it down. Then focusing on the next number, which is 9. So 3 times 3 is 9, and then 3 times 1 is 3. Then focusing on the 25, so 5 times 5 is 25, and 5 ones are 5. So here our HCF is, since we do not see a common factors in this prime factorization method, so definitely it will be 1. And for the LCMs, we have taking the product of these numbers, so we are going to get the LCM as 1800. So moving forward to the next question. So given that HCF of 306 and 657 equals to 9, find the LCM of 306 and 657. So we are given the HCF, but we are not given the LCMs. So we have to find the LCMs by using the given HCF, which is 9. So for that, what we are going to do is, we are not going to start with prime factorization method. Rather, we are going to do the formula, using the formula, which will be much easier. So LCM times HCF is equals to product of the two numbers. So here LCM is not given, but HCF is given as 9, and the two numbers are given as 306 and 657. So now next, what I'm going to do is, since we need to find the value of LCM, I'm going to keep the LCM to the left hand side itself, but this number 9, I'm going to take it to the right hand side. So the moment I take the number 9 to the right hand side, what happens is it will go down in the denominator, because in the left hand side 9 is in the multiple with the LCM, so it will go in the opposite of the multiplication, which is the division. Now when you take the 9 down, what happened is 9 and 306 are divisible, so 9 times 1 is 9, and 9 times 34 is 306, which means our LCM is equals to 34 times 657, which is equals to 22,338. So this is our LCM by using the formula LCM times HCF equals to A times B. So next, so question number 5, if you remember, this is almost the same as what we have done in the example. So if you have not gone through that, please refer to the last video which I have uploaded. So here you are asked to find whether the 6 to the power n ends with the digit 0, where n is a natural number. So using the previous knowledge, so we will just solve this one. So we are given a number 6 to the power n, and this n is a natural number. So for natural number 1, our 6n will be 6 to the power 1, that is 6. And for natural number 2, our 6, it will be 6 square, which is equals to 36. And for natural number 3, our 6 to the power 3 is equals to 216, and likewise. So now we can denote 6 to the power n as 2 times 3 to the power n, right? So 6 being the composite number, we can represent it this way. So we can denote 6 to the power n is equals to 2 times 3 to the power n. And since the prime factors of 6 does not contains the prime factor 5, therefore 6 to the power n for any natural number n does not ends with digit 0. Here what we have said is the 6, which is a composite number, we can represent it in the form of product or primes, but in this prime factors we do not see the prime factor 5. So if 5 is missing, what happens is 5 times 2, we are going to get 10, and any number with a product of 10 will have a number ending with a 0. So since we are missing the number 5, so therefore this number 6 to the power n will never ends with a digit 0. So moving forward to the next question. So here we are given two numbers and we are asked to explain why these two numbers are composite. So which indicates these two numbers are actually a composite. We just have to explain why they are composite. So first we will try to explain the first number, which is 7 times 11 times 13 plus 13. So if you see here, these three numbers are in product form and this number 13 is the separate number. Here what we are going to do is this 13 and 13, so we are going to take the 13 as common, right? So these two are the separate terms. So in the first terms we see that 13 I have taken it outside, so we are left with 7 and 11, right? And the plus we will just write it down, and this 13 I have already taken it out, so which means 13 times 1 is 13. Next, 13 times 7 and 11, it is 77 plus 1. So 13 times 77 plus 1 is 78. So 13 is a prime number, but 78 is a composite number. So this 78, I have to express this as a product of primes. So 78, I am going to take the product of primes by using the prime factorization method. So 2 times 39 is 78, 3 times 13 is 78, and 13 times 1 is, so which means 78 I can write it as 2 times 3 times 13. So therefore 13 times 2 times 3 times 13. Now if you look at this number is in the form of product of a prime number, so which means definitely you're going to get a composite number only. So this is according to the fundamental theorem of arithmetic. So yes, so we have shown it. We have shown that 7 times 11 times 13 plus 13 is indeed a composite number. So next we have 7 times 6 times 5 times 4 times 3 times 2 times 1 plus 5. So again, this is almost the same as the previous question. So here from 7 until to the number 1, they are in the product forms, while this number 5 is the separate numbers. So we have two different numbers. So what we are going to do is this 5, I can see it over here as well, so I'm going to take this 5 as a common. So except for the number 5, I'm going to represent the rest of the numbers here. So 7 times 6 times, so 5 I've taken it out, so 4 times 3 times 2 times 1 plus 5 times 1 is 5. Next, what I'm going to do is 5 times, take the product of 7, 6, 4, 3, 2, 1, which I'm going to get as 1008. Then you just have to represent this plus 1. Now 1008 and 1, if you add it, what you will get is 1009. So 1009 is already a prime number and 5 is already a prime number. So when you find two prime numbers, that too in the product forms, you're going to get composite number only. And thus we have explained why those two numbers are composite numbers. So the last question of this exercise is, there is a circular path around a sport field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they start at the same point and at the same time and go in the same direction. After how many times will they meet again at the starting point? So you are given a circular path, all right, and there are two persons. The first person is Sonia and the second person is Ravi. So these two persons are standing exactly at the same point in that circular field, and they are going to take some round on that field. So they are starting at the same point and they are moving in the same directions. But the only difference is Sonia is going to take a little more minute than the Ravi. So her speed is a little bit lesser than the Ravi. So Sonia is taking 18 minutes for one round. So to make one round, she is taking 18 minutes, while Ravi is taking 12 minutes for that same one round. All right. So our question is, after how many minutes will they meet again at this starting point? So while they will take the round, so definitely Ravi is much faster than the Sonia. So in one round, definitely Ravi is going to lead. So our question is, at what time will Ravi and Sonia will be exactly at the same starting points? So for this, we have to understand that you have to find the LCM of these minutes, right? So then we will try to find out the lowest common multiple. So 18 and 12, so we can represent it as, so 18 and 12, the common factors are 2. So 2 times 9 is 18, 2 times 6 is 12. Then we have 3 times 3 is 9, 3 times 2 is 6, and 3 times 1 is 3, and 2 times 1 is 2. So here the LCM is equals to 2 times 3 is 6, 6 times 3 is 18, 18 times 2 is 36. So at 36 minutes, they are going to meet at the starting point. Alright, so with this we are done with exercise 1.1. So we will meet again in the next video, which will be exercise 1.2. And thank you so much.